Hello and welcome to this video tutorial which is going to be on BGP Site of Origin, which is also known, and I actually should probably flip these around, as the Route Origin Extended Community attribute. We're going to be taking a look at RFC 4360, and so the standard defined it as the Route Origin Extended Community attribute, and Cisco refers to it as the Site of Origin. And so we're going to refer to it here as the BGP Site of Origin. And we're going to be taking a look at the really sort of the well-defined use case, although when you look through some of the documentation and specifically a number of the recent Cisco Press books that are out there, they'll mention Site of Origin, but one of the things that really isn't mentioned is sort of bringing it into context and answering that question, when would I use BGP Site of Origin? What is the use case where I as a service provider would look to use that, and what problem does it solve? And so we'll start right there. So what is the use case? Well, the use case is if your site is multi-homed to the same service provider, and the service provider is using an MPLS L3 or IP VPN network, and the service provider is using the AS override option. And so this one here, this is really the key that when you poke around, you don't find a lot of reference to the AS override option, and that's on the service provider side. That would be on the PE routers, and this here is PE1, and this is PE2. The AS override option is what the providers will use on their peerings in the VRF peerings that they have with the customers excuse me, to basically override the customer autonomous system number. So in this case here, you can see the customer is using 65001, right, for their site. And this is also key here, your site. Well, how does BGP, and it's all about perspective, right? So how does BGP define a site? Well, it's not based off location, right? So we could say that this router's in Santa Rosa, California, this one's located in Crofton, Maryland, and they're using the same autonomous system number. BGP is going to treat those as being in the same site because they've got the same autonomous system number. And so this drawing here on the top, the drawing on the top and the bottom, it's the exact same drawing with just a different perspective. So when I draw it like this, and I say, oh yeah, this location is in California, this location's in Maryland, but BGP is going to see that as the same site, irrespective of the disparity in the location. And then down here, it's the exact same drawing as you have up here, except we've got this one big cloud depicting AS65001. So this router could still be in California, and this router could still be in Maryland, and BGP doesn't care. BGP is looking at the site, and the site is defined as the autonomous system number. And the reason I did this isn't to confuse you, but sometimes you'll see it depicted like this, where you've got the autonomous system on the left and autonomous system on the right, giving you the impression that, oh, site is location based, and it's not. When we're talking about BGP Site of Origin, it's the autonomous system is the site defining characteristic. So when we have the same autonomous system number, we have the same site. Again, irrespective of the fact that the sites may be, 3,000 miles apart. So the site is multi-homed to the same service provider, MPLS IP VPN network. The service provider will have to be using the AS override option. And you may ask, well, why is that? Well, it's a simple fact that BGP, what is the natural BGP loop prevention mechanism? Because that is really what Site of Origin is going to be used for. to prevent loops in BGP. So as soon as I say that, you're probably saying, well, wait a second. BGP already has a loop prevention mechanism. It's the AS path. And if I were to clear the slate here, when we look at this, you're probably thinking to yourself, well, hold on. AS65001. So if this router generates or introduces NLRI, network layer reachability information. In other words, a fancy name to say a prefix in its length, right? And it sends it in here to the provider core. And then the provider core is going to generate a VPN v4 routing update that it's going to send over here to the PE2 router that is then going to look at the import-export statements on the route target, and if it matches, it's going to send it over here. But you're probably thinking, well, wait, the AS65001, it's going to drop that because it's going to see its own autonomous system in the autonomous system path. And you're absolutely right. And that, without any alteration to BGP, that is how BGP will function. But what we're saying is this AS override option, and that's why I'm saying that this is the use case, that option has to be in play here in the provider on the PE router. And what that option does is when the BGP update message shows up here in the VRF, and we'll say this is customer A, for customer A, the PE router is going to say that customer A's autonomous system number, which could be any autonomous system number customer A chooses, the provider is going to override that and stick their autonomous system number in there. So when it gets communicated over to PE2 and then ultimately out here, and this peering here is AS65001, what's going to happen is customer edge 2, this router here, is going to be receiving an update that's going to have 67.67 as the autonomous system number. So then, of course, this obviously leads to the question, well, why would the provider do that then? Why would the provider introduce a scenario overriding the BGP natural loop prevention mechanism? Well, again, it could very well be that the customer wants to use, or, and this is a stretch here, has to use a private autonomous system number for whatever reason. And it's going to be the same on both of these routers in this peering. And so at that point, the provider can say, okay, well, we've got a whole bunch of customers that are going to be using private autonomous system numbers, so therefore we'll just override that on our PE routers. And remember, this AS override, we're going to see this when we get onto the command line. The AS override is something that is done in the outbound direction. And you'll see that when we start to generate NLRI or advertise prefixes along with their prefix length into BGP so that it can be shared across the cloud, again, coming into that same site, it's going to be prevented by the natural AS path loop prevention mechanism. However, as soon as you introduce AS override into the equation, that, again, it basically turns off BGP's natural loop prevention mechanism, which is the AS path. And so finally here, you've got the third criteria, right? The third criteria of the use case where you would say, hey, we need to use BGP site of origin. The third criteria is you've got an iBGP peering. Now, I put backdoor here. I don't really like that term backdoor because it sort of implies that it's some sort of like secret link that no one knows about. Well, if you're the same site, right, the same autonomous system here, there's a very good chance that you're going to have this iBGP peering, right? And again, it could be over a great distance. Down here, right, this perspective, right, it could be, these two guys could be in the same rack. And this cable could be a direct connection between these two routers in the same rack. But again, you need to have that, or at least in the use case where you would want to use site of origin, this iBGP peering / backdoor link needs to be there, because without it, there really is no loop. And the loop is best seen here. Not so much, well, it's represented like this, right? It's a little crazy to think, oh, it comes over here and then we're going to come back over this backdoor link. When it's like this, it makes a little more sense, where let's say the loop back, which is what we're going to advertise, gets advertised up here to PE1, to the service provider. And then PE1 is then going to advertise that over here to PE2. And then PE2 is going to advertise that down here to CE2. And then CE2 is going to advertise it over here back to CE1. And again, once it's originated here, it's going this way as well. And so that's what the site of origin is for, right? There's three things that need to be in play for the site of origin to come in as an architectural decision. And let's review them one more time. We're going to get on the command line here. So the first is your site is multi-homed. And remember, we're defining site as the same autonomous system number. Because if it's not the same autonomous system number, let's say over here in Crofton, we decide to use autonomous system number 6. Well, then guess what? That is not going to be a BGP peering. By definition, you know that for this to be an iBGP peering, it has to have the same autonomous system number. And so really, 3 and 1 are tightly coupled in terms of the criteria that needs to be met in order to say, hey, we are going to have to think about using BGP site of origin here. So, and that sort of supports the use of the definition I gave earlier of site, the same autonomous system number. So your site has to be multi-home to the same service provider, MPLS IP VPN network, and the service provider needs to be using AS override, and finally, we need to have this backdoor / iBGP connection. So if those three things are being done, then we need to talk about BGP site of origin. Because what BGP site of origin is going to do is it's going to allow us to basically tag the prefixes that we're learning from the customer. And when I say we the service provider, because the site of origin is applied on the provider edge routers, on the PE routers to which this customer who meets these three criteria is connected. And there's a multitude of ways that we can set the site of origin, but what it is, it's simply nothing more than an extended community attribute that we are going to apply or append or label the customer's prefixes with, that when they show up to the other PE router and he says, oh, I'm going to go ahead and send those out to the customer, no. The PE router is going to examine those extended community attribute, site of origin, and if we have it defined here and we have it defined here, the provider will deny the advertisement of those prefixes out to the same customer. And again, it almost makes more sense looking at it as this square. So we define the site of origin value here, and it's literally a 2-byte value and then a 4 or 2 octet value colon a 4 octet value. So I could have 1:1, and that could be my site of origin value. It could be 99:99, but I define it, and again, has to be on both provider edge routers. And I define it over here, and all the NLRI that come in from CE2 to provider edge router, and whoops, that's a typo, sorry about that, PE2. Did I do that up here again? Yeah, I did it up here again. So, but all the NLRI that is originated from CE2 that is advertised to PE2 will be tagged with the extended community attribute 9999. And the same thing, everything originated from CE1 that is advertised to PE1 gets tagged with the extended community attribute 99:99. That way, when the two PE routers send their VPN v4 updates back and forth, and they see, hey, these prefixes are that I'm receiving, so from PE1's perspective, the NLRI that I'm getting from PE2 has the extended community route origin attribute defined, and it matches what I have defined for that customer VRF, then I am not going to advertise it. And PE2, the same thing. From PE2's perspective, he receives a VPN v4 update from PE1, and in that update, that NLRI has the extended community attribute for route origin defined, which is site of origin in Cisco speak, has that defined, and it matches what PE2 has defined for the VRF with CE2. It will not get advertised. All right. So let's go ahead, let's jump on the command line. Again, a lot of background information there, but I want to make sure that I clearly define the scope of when you would use this, because that's one of the things, again, you'll see it referred to, and in fact, I think I actually have a Cisco document. So you'll have it referred to like, so here's the Cisco document. This is their documentation, BGP per neighbor site of origin configuration. If I do a search in here for override, right, you can see it's, but this is an AS override. There's no mention of AS override in here. Now, again, the document is pointing out how to configure it. So it's not discussing it from like an architectural perspective, but again, there's no mention here of, well, wait a minute, when would I want to do this? This, again, shows you how to do it, and I'm sure there's a document somewhere that'll talk about, you know, the when you would want to do it and not so much the how. But this is one of those things that when you look at it, it kind of becomes confusing, or it can become confusing if you're trying to figure out, okay, well, do I apply site of origin to everything, you know, on all my VRFs on the PE routers, or is it only in certain instances, right? So there's no mention whatsoever here about AS override, and that is really sort of the long pole in the tent is, well, I guess, you know, we'll say all three of those things are the, you know, the requirements or the use case that we laid out here. Those are really the long poles in the tent, is that you need to have those three things. Without all three of those things, there's really no need for site of origin, right? Because again, we are overriding, we the provider are going to override BGP's natural loop prevention mechanism. And when we have a customer that is multi-home to us who is doing IBGP in their network between the two routers that they're peering with, or not even just those two routers, but IBGP with those two routers, and it could be other routers, that's when we want to think about site of origin. So let's go ahead and jump in to the command line here, and everything is already set up in terms of the MPLS L3 VPN. All of the peerings are already set up. So here we are in router 6, and this is PE1. And so we've got it set up here to say PE1. So if I were to say show run section BGP, right? So here is our BGP section. And this is where we have our multi-protocol IBGP peering for the VPN v4 information with the other provider router, PE2. But here's the address family IPv4, right? And again, it's a very simple VRF configuration. So let's look at router 1's configuration. This is the customer edge router, CE1. So if I were to say show run section BGP, you can see excuse me, we have our iBGP peering, which is that quote-unquote backdoor iBGP peering link, and then we have the peering with the service provider. Now I'm also originating two networks here. They're both loopbacks, simply 1111 and then 11111111, because we're going to use those here later on. Now on the other side of the cloud, right, of the other side of the provider network, we've got CE2. So on CE2, if I were to say show IPBGP, you can see, and this is what you would expect to see in this setup that we have. Because again, AS override is not in play right now. So what's in play is the iBGP peering, and that is what you see down here when we look at the BGP routing table, not the global routing table. This is the BGP routing table on the customer router. You can see we've got the I here in the third column in the status codes. And when we look at the status codes, how was it learned? It was learned from an internal peer. And we know it's the internal peer because we've got this giveaway here, the next hop, and that is router 1, CE1 router 1. That's who we're learning this information from. But why are we not learning it from PE2? Why is that? So let me clear the screen here. And that's an important question, because what we're talking about really is BGP's natural loop prevention mechanism. So I'm advertising 1111 and 111111 here and over the iBGP peering. So to the provider and to the iBGP peering. Now the iBGP peering sees it, but it gets here and then it comes over here and then it's going to be advertised here, but it's not showing up as being learned from PE2. And it's all because of BGP's natural loop prevention mechanism. But let's not just talk through that. Let me show you that that is actually what is going on. So here's what we're going to do. We're going to debug BGP IPv4, or no, debug BGP, sorry about that, BGP, and we want to do, yeah, IPv4, I was right. So IPv4 and unicast, and we want to look at the updates. Yep, we're going to take a look at the updates, right? So here's what I'll do. I'm going to withdraw, or I'm just going to shut the interface down for loopback 0, which is our 1.1.1.1. So when I say shut down, this is going to shut the interface down. BGP will no longer, or there will no longer be a way for BGP to recurse to the next hop, or this is no longer in my global routing table, the RIB. And so BGP, seeing that it's no longer in the RIB, is actually going to go ahead and withdraw the route. And just hold on one second here. My apologies there. You hate it when the phone rings. So we're going to shut the interface down. It's going to remove the interface from the global RIB. BGP is going to see that it's removed from the global RIB, and it's going to say, hey, I think that's great that I've got a network statement for that network, but I cannot advertise in LRI that is not in the global routing, that's not being used on this router. So it's going to send out withdraws. So let's see what happens here. So I'm going to shut the interface down. Again, we're debugging over here, and take a look at what happens. In fact, this is fantastic. So I tell you what, I love the debug output. Some of the best output that you can get. So we withdrew the route, right? Or we withdrew the route from router 1, and you can see here, BGP update comes in, update message comes in. Who's it about? It's about that in LRI, and we know that we're sending a withdraw message, right? There's no valid path for 1.1.1.1 anymore. And so it's going to be withdrawn. And then this is what I love. A withdraw message also, and this withdraw message comes in from, this is router 1 over the iBGP peering. But then what do we see? Take a look here. We're also getting a withdraw message from who? Router 7 PE2, saying, hey, basically saying the same thing. It's unreachable. And here's it comes in the attribute with the next hop, and it gives you the originator information. and then there is the AS path information, and there it is, extended community, right? We've got the extended community set, but then what does it say here at the bottom about that? We received the update. It was going to be to withdraw, but it's denied due to AS path contains our own AS path. And there it is. There it is. So it's been denied because the AS path is our AS path. So if I were to try to reintroduce this NLRI, right, or that, I should say, that prefix that we're dealing with there, right, let's bring it back up. So we'll come over here and I'm going to say no shut. So what's going to happen is BGP, and you'll see, it should be like a little cascading thing here where you'll see, well, actually we're not debugging there, but it makes its way over here and we get our update messages, and it's going to come in with the same AS path. And you'll see here that we get the update and it hits from PE2 and it gives the information for PE2. What it didn't show me though is it didn't show me the removal. So if I'm on CE2, if I say show IP BGP here, we don't have two routes or two prefixes here, or I should say two routes to that same prefix. We still have only the single entry for the next hop to the iBGP peer, but it's because the AS path matches. But we should have seen that in the debug. And actually, let me go ahead and do a debug BGP IPv4, and it should have been in the updates. We should have seen it get kicked back. It shouldn't be events, it should be updates. Let me make sure. Let me do updates inbound. And let me see if that changes. And actually, we could do 169. Let's put this in here just to see 254.47.7 in. All right, and let's see if we can see that, because it should show you. And we'll go ahead and we'll say shut. So we'll shut it down, and that's going to withdraw the information. But when it goes to advertise the information, yeah, and there you go. We can see on the withdraw, we see it. We should see it as well when it comes in if I say no shut. So we'll bring that interface back up. And we should see that route advertised from PE2. You can see here it says revise installing route. And so we're sending the update. It looks like our update is being sent to PE2 before it sends it to us is what's happening. So we're actually sending the withdraw to PE2 before it comes from PE2 to us. Because if it came from PE2 to us, this is what we would see. Is we're going to reject it because it's got RAS. And so that is BGP's natural loop prevention mechanism. So let's go ahead, let's work on the first criteria here. So what is the first criteria? We're multi-homed. Great. So now we're going to work on the second criteria, the AS override option. So let's go ahead on the PE routers and let's put in AS override to see if this changes anything. So we're going to go to privilege exec in the global config. We'll say router BGP 67.67, and then we're going to go into address family. VPN v4, or no, I'm sorry, IPv4. We had that right. IPv4 VRF unicast, or I'm sorry, VRFA. So there we go. So we'll say do show run section BGP. And so here we go. Excuse me. We're in the VRFA. And so actually, probably the best thing to do here, let's do this. We're going to go over here to router 4, and we're going to go to interface fast Ethernet 00. So I'm going to shut down that sort of that iBGP backdoor link. We're going to go ahead and shut that down. And this is actually going to be the best way to show you the AS override. And so before I do this, let's come over here And we are doing a bunch of debugging. And you can actually see we just received an update denied due to our own AS path. So we've got the natural AS path, the BGP loop prevention mechanism in place here. So let me do this. I want to withdraw, let's see, show IP BGP. So we should be, what do we see here? All right, so the 1.1.1.1. So let's go into global config, interface loopback 0. And let me give it a second here. It looks like we're going to have to wait for things to converge, actually. Because BGP, we should be learning the routes from the 169.254 from PE1. So CE1 is going to be learning things from PE1 here in just a second. In fact, let's do a do clear IP. Well, actually, let's see. Do clear BGP VPN v4 star soft, I believe. What are we doing here? So let's say, excuse me. So we'll say clear BGP VPN v4 is correct. Oh, unicast. So I left the unicast out. Star soft. Whoops. All right, so we've got that. And let's see if that helped anything along here. Oops, sorry, on that side. Do show IP BGP. Do clear IP BGP star soft. So we'll do an in and out refresh here. Yeah, it looks like we're going to have to continue to wait. We'll do it across the board. Do clear BGP VPN v4 unicast star soft. And do clear IP BGP star soft. All right, let's see what we've got here. Okay, there we go. So that's what I was looking for. So you can see we're getting these updates, right? And so now the updates are coming in across the MPLS layer 3 VPN network, but we're getting the message that we expected to see, which is these prefixes that we're supposed to be learning, this NLRI, is being denied because the AS path that it's coming in with is our own AS path, which is AS 65001. So when I say do show IP BGP here, and we get that out of the way, do show IP BGP, we should only see the 4.4.4.4, and that's that locally originated route. It's the same thing over here with router 1. Do show IP BGP, CE1, only sees the locally originated prefixes. All right, now let's go ahead. So now let's turn on AS override and let's see what happens. So we're going to go into global config, router BGP 6767, address family IPv4 VRFA, and we're going to say neighbor 169.254.16.1, and it's just simply AS override. Now, in fact, I'll go ahead and leave it here on just PE1, router 6. Let's say do clear IP, or actually do clear BGP VPN v4 unicast star soft, and I'm going to try to force this scenario here where it'll show the directionality of the AS override. And by the directionality, I mean, do we see do show IP BGP? Ah, perfect, it worked, just as I was hoping it would work. All right, so I say do, I did a do clear BGP VPN v4 unicast star soft. And so what do we see? So the AS override is working in this direction. And when I say this direction, we're picking up that 4.4.4.4 prefix, and you can see what's happening here. We've overridden the 65001 autonomous system number that it should have shown up with. Now what it shows up with is, and this is the AS plain notation, for a 4-octet AS number, which is 6767. So that's basically the integer for 6767. But we're picking it up, and look who we're learning it from. We're learning it from PE1, router 6. So I set the AS override on router 6, and when the prefix showed up, this BGP update shows up at router 6, PE1, from PE2 router 7, the AS, autonomous system number, is overridden and it substitutes the service provider's autonomous system number for the originating autonomous system number. But let's see, does it do it in the other direction? Whoops, let's come over here to CE2 and I say do show BGP. And what do we see? No, it doesn't. Right? So it's in the outbound direction. It'll be the outgoing provider edge router that is going to do that AS override, or the provider edge router through which the prefix is traveling to get to the customer edge router. That is where it takes place. It's not on the inbound. If it was on the inbound, then router 6 would have overridden the prefix it learned from the CE router. So what we can deduce here, and what we see in the behavior of the AS override, is it's being overridden in the egress direction from the provider edge router, right? It's all about that perspective. The provider edge router egress is where the AS number is being overridden. All right, so let's go ahead and let's set the same thing up here. Let's go ahead and do show run section BGP. Where are we at here? And I should be in the right AF interface. Let's say neighbor 169, or address family 169.254.47.4 AS override do clear BGP VPN v4 unicast. Keep forgetting that unicast. Unicast star soft. And you can see here we have the little blue update on router 4. Let's see what that is. And check it out. It's a revision. It is now installing these routes into not only the BGP routing table, do show IP BGP, but it's also installing them into the global routing table. And you can take a look here. What is the next hop address? It is PE2, right? And over here we've got the AS, the BGP AS notation dot set, so you can see the autonomous system numbers in the AS dot notation as opposed to the AS plane. And so take a look here. What do we have? You can see that the 65001 has been substituted for with the provider's autonomous system number. And so this is sort of the second part in this equation for when do we do BGP site of origin. So your site is multi-home to the same service provider, MPLS IP VPN network, check. The service provider is using the AS override option, check. And finally, you've got IBGP backdoor link. You've got a peering taking place, right? IBGP peering here between the two CE routers. So let's pull that back online, and then let's deal with the site of origin configuration, and we'll look at how we can confirm and validate that that's actually what is being set. So let's get into, I think we're here, interface FA00. We're going to say no shut. So we're bringing up that backdoor link right now, and let's go ahead while that's coming up. Let's talk about the 3 different ways that you can actually set up the site of origin. So the first, which is a new feature, well, I shouldn't say not totally new, but it's actually discussed, if you look here, talks about it in the 1249T, is where this neighbor site of origin configuration was initially introduced. Now, this is not the only way to do it. This is when this neighbor site of origin configuration was done. There's 3 ways we can deal with it. You can do it with a peer policy template. You can do it with this neighbor command. You can use a peer group, and the original way that it was done when it first came out was you would just set it in a route map. You would set the extended community site of origin to whatever you wanted your value to be. So, excuse me, we'll go ahead and we'll deal with the easiest way first, which is going to be setting it up with the neighbor statement, right? So do show run section BGP, and I think I'm already in the right address family. So literally, and this is what's so great about that document that I just showed you, if you simply say neighbor, and actually before we do this, let me run one command here. So I'm on PE1 router 6. So if I was to say do show VPN v4 unicast, and or actually is it going to be VPN v4? I think it's unicast VRFA, and let's take a look at the prefix we're going to be getting from. Oh, do show BGP actually is what I want. Show BGP VPN v4, and I'm pretty sure we need that. Yeah, the unicast in there, VRFA, and 4.4.4.4/32. So here we go. So this is what we're interested in seeing right now. So you can see here that this provider edge router, PE1, is learning 2 paths to get to the 4.4.4.4. It's learning the one, right? The first path here is through router 1, through CE1, and that's the BGP router ID for CE1. And then the second path, it's learning through whom? PE2. So it's learning through CE1 that it can get to the 4.4.4.4, and it's also learning to get there through PE2. Now, which is the best path? You can see right here there's 2 available, and the best is 1. And again, in the scenario that we've got, if we walk down sort of the best path selection algorithm where we start with the weight, well, the weight's not set in either one. Then you go to local preference. Local preference is 100, so we've got a push there. We then work down to, was it locally originated? No, it wasn't locally originated. We go to the AS path. The AS path length is, in both instances, 1, right? And this is also showing you that the AS override, the substitution, this 4444, where is it coming in from? Right? When it comes in from PE2 here, you can see that it's not doing the substitution on the ingress to PE2. Because if it was, this would be 67.67 and not 65.0.0.1. It's doing it on the egress to the other customer edge router through PE1. And so after AS path, we go to lowest origin type. Well, these are both originated with the IGP. And I'm sorry, that's the origin code, origin type. And then we go to the med value, and the metric is 0, right? And the metric is not here, so it's going to be 0. And then we hit the 7th selection point, which is EGP over IGP, learned by EGP neighbor versus an IGP neighbor. And that is how you end up with this path as the best path. So here's our extended community, right? So the route target, very simple, right? We just did 1-1. Excuse me. And this is where we're going to see the extended community for the site of origin. So I wanted to show you this first before we add the site of origin in there. So let me go ahead and clear our palette here. Whoops, let's clear that off. All right, so we've got that cleared off. Now let's go ahead using the neighbor command and let's set up the site of origin, the BGP site of origin. Router BGP, address family, IPv4 VRFA, and it's simply going to be neighbor 169.254.16.1, and I simply type in SoO, so site of origin right now. The first value here is 2 octets, right? So this is, I was thinking about this earlier in the week, that if you're pairing with a customer and you're the provider and the customer is using a 4-octet autonomous system number, you can't represent that here because this is a 2-octet value on the left-hand side, and then it's a 4-octet value on the right-hand side. And so it says IP address and then :NN. So if I was to say, I could put an IP in there, but if I was to go to 65, let me see if it'll take it, 65.5, Or actually, let's just put a bigger number in there, 333. Oh, wait, sorry, :9. Let's see if it takes that value. Yeah, it does take that value. So it takes a larger value. I think the original, the RFC had this as a 2-octet field, and that is a 4-octet field. But yeah, it definitely will take the larger value. But let's pull that back. We're not going to use random values like that. So we're going to say site of origin. And again, this could match. I could say 65001:1, right? But whatever value that we use in this site of origin statement on this PE router, we need to have a matching site of origin statement on the other provider edge router that's peering with the customer. So I'm going to say 65001:1. And it's pretty straightforward. I'll come over here to router 7, and we're going to say the same thing. Neighbor 169.254.47.4, and the site of origin value is going to be 65001:1. And we'll hit enter. And let's say do clear BGP VPN v4 unicast star soft. And we'll run that same command over here. Do clear BGP VPN v4 unicast star soft. All right, so now for all of the prefixes, all the NLRI that each PE router is learning from its respective CE router from the customer, we're going to tag, right? Affix this tag, this extended community tag of 65001:1 as the site of origin. And the PE routers are going to look to see if they receive an update that's matching the site of origin that they have configured for the neighbor. They will not advertise to the neighbor. So now let's take a look at do show BGP VPN v4 unicast for VRF-A, and let's look at 4.4.4.4 now. And I don't see, and let me see, actually I think I'm looking at the wrong one on PE1 here, 1.1.1.1. And it's not showing. And let's do this. Let me withdraw the route and then re-advertise. We'll go to global config interface loopback 0, and we'll say shut. So we're going to shut down the 1.1.1.1 loopback interface here. And then I'm going to re-advertise, re-originate that. So we'll say no shut. And let's see. All right, so the network's not in the table. So we'll wait for the update to kick in here. Okay, there we go. All right, good. So as you can see, we've got our site of origin. And let me make sure, I didn't miss that before, did I? No, I definitely did not miss that. Okay. So yeah, we just had to withdraw it and then re-originate it. So here is the site of origin value, the extended community site of origin value, and you can see that it's the exact same value on PE1 as it would be for that route. Let's say Control U. Do show BGP VPN v4 unicast VRF-A 4. We'll check out 1.1.1.1/32, and sure enough, there is the site of origin community. So when PE2 receives the update for the 1.1.1.1, it's going to see that, hey, wait a minute, I have a neighbor statement in my BGP config setting the site of origin to this value, which is labeled on this update, on this prefix within the update. Therefore, I am not going to advertise this back out to that same customer, because if I'm receiving it from another provider edge router, what that means is I've already received it from the customer, just not the CE router with which I'm peering. which is CE2. And the same thing goes in the opposite direction if we look at the 4.4.4.4 prefix, which is originating from CE2 and going to, and it looks like we may have to re-originate that. All right, slight oversight on my part, so we're going to global config interface loopback 0, and we'll say shut. So that's going to shut down the 4.4.4.4, but then we're going to bring it back by saying no shut. And that'll bring it back up. Now we should see it. We'll see how quickly it happens here. Yeah, so you can see network's not in the table right now because it was withdrawn when we shut the interface down. But as soon as the BGP update reaches the PE router PE2 from CE2, you're going to see, and there we go. All right, and there is our site of origin setting. Now, again, the conditions that were met were multi-homed to the same service provider, and actually let's go back here real quick. So we're multi-homed to the same service provider, we're using the AS override command, and we've got the BGP backdoor. So since we're doing those three things, since those three conditions are true, we need to use the site of origin because there could be the possibility of a loop, a routing loop, right, caused by a race condition where updates and withdrawals aren't being received in an order of operations fashion, right? So we need to protect ourselves against a routing loop with the customer, and it's the BGP site of origin that accomplishes that. So now if I come back here, let's go ahead and take a look. We should be able to see, and if I'm on, I'm trying to think here if we would run that from the PE router. Let's see if it's the PE router. So let's say, I believe it's debug. No, it's going to be debug. No, I think it's on the client edge. What I'm trying to see here is do show IP BGP. So here's what the BGP table looks like right now. If I say debug, and you can see we're only learning the information from the iBGP peer. Let's see here. So it's going to be debug. What is it going to be? BGP IPv4, unicast. I think we're already doing this earlier. Updates. I think that may show us what we're looking for. We'll say, oops, sorry, not int, inbound. And it might be on the PE router as well. So let's do this. We'll do it on both. So debug, BGP VPN v4, or no, maybe it's IPv4. IPv4 unicast. Can we do it for the VRF? No. Updates. Out. All right, let's see. So what I'm trying to capture here is if we can see the denial or the route not being advertised out because of the site of origin. So we're able to see the site of origin with that show BGP VPN v4 unicast VRFA and then the prefix that we're looking for. All right, let's say no shut, and let's scurry back over here. Okay, so we can see that it's withdrawn. Let's see if we get an update saying that it's not going to advertise it to CE2 because of the site of origin setting. Let's see what we've got here. We should see something here shortly. I did say no shut, correct? So it changed to up. And it could be that we're not going to see that. Look like it may have updated and installed it already. Yeah, I thought that would show us on the PE router. Let's do debug IP BGP updates, but I don't think this is going to show it. All right, let's do a quick shut, and then a no shut here. All right, so that's showing that it's got the withdraw, the modification, and then let's bring it back online here. No shut. All right, let's see if it catches anything. And I don't think it is because it already lit up here, showing that the route is being installed in the main table. Unreachable format, yeah, but it doesn't mention, and there it is right there. So update format, okay. So yeah, nothing about the site of origin in the debug, and it could be that I'm just not remembering the right debug. But let's do this. Let's go ahead and see what this looks like in Wirehsark. So I'm going to kick off a capture here, and let's generate the update. So let's bring back, so we'll say shut. So we'll shut the interface down, and basically where the packet capture is taking place is between the two PE routers, because that's where those VP and V4 updates are going to be taking place, and that's what we want to see. That's sort of the information that's going to be of value here, and we're going to be looking for a BGP update, and typically there'll be two TCP messages that take place right after it that are going to be sort of black and red. And there they are right there. Let's see, did we get that BGP update? I did not see the BGP update there. And it could have been that I missed it. Let me scroll back, because usually the BGP update is right around, yeah, you can see right here, it's PE1 and PE2 talking to each other. And where is that BGP update message? All right, let's let this go one more time here. In fact, what I'll do is let me originate the 11.11.11.11. Let's see what we see right now. Show IP BGP. So we actually already see the 11.11.11, so let's do this. We'll say shut. And we should see, unless the withdraw is getting there, unless it's coming in from CE2 faster than it's getting there from PE1. And so then we would not see it, I do not believe. So there's those TCP. Oh, and there was the update. Okay, I guess I may have just gone by too quick, or not waited long enough. All right, so let's go back here, and now we're going to say no shut. So we're going to bring the interface back, and there's the update. That's what we're looking for right there. So here was the guy that I was looking for, is the BGP update. So if I were to double click on this, and then let's make this a little bit larger here, you can actually see, we're going to be able to see, we don't need to see the TCP information. So here's the BGP information, right? And there's that multi-protocol reachability in LRI, which is the multi-protocol BGP. You can see here's the path attribute, and what we're looking for and what we want to focus on, the extended communities right here. So you can see the type code is 16. They're optional, transitive, and how many extended communities are we carrying? Well, we're carrying 2. Yeah, the 2 octet AS route origin is 65001:1. The community type high for the 2 octet AS is 0x00. The subtype AS is the route origin. And so if we go back to the RFC, where we talked about route origin, right? This is where that is defined. And so if I scroll down, and here is the BGP Extended Community attribute. So when we saw that high and then the low, so the high was the 0x00, and the low is the sub field. And so you can see here, we've got, there's a regular type and an extended type, but we're talking about the extended communities here. So if I scroll down a little further, you can see that of the 8 octets, the first 2, which are the high and the low that we're talking about, it talks about whether it's an IANA authority bit or a transitive bit, and then the value field, which carries the value that we are interested in. I'm looking for, there we go. So you can see here 0x00, and then there's a subtype. So this is the 2-octet AS specific extended community, which is exactly what we are looking at. And I think it's going to force me. I wanted that window back. There we go. That's the window I'm looking for. So here you go. See, there's that type high, 0x00, and that's what we're seeing in this field right here, 0x00. And then we have the subtype. If I scroll down a little bit further, the subtype is defined. Or did I go right by it? 0x. I think I may have gone right by the subtype. So the subtype is 0x03. Let me make sure I didn't go far enough. Route origin community. Here we go. And you can see the low order octet type field for the community is 0x03. And that's what you're seeing right here. And that indicates that route origin. Again, the RFC, which was the universal standard, initially referred to it as a route origin. In fact, nowhere in RFC 4360 does it say site of origin. It simply says route origin, right? So there's the first field value, there's the second field value, right? And that is what we are seeing when we're looking at that RFC. And then we get down to the community transitive 2-octet AS. This is the route target extended community that we're using in the L3 VPN, right? The MPLS layer 3 VPN. So again, you'll see these values in Wirehsark, and it can be very valuable to come in, take a look at these values to understand where these originate from and exactly what they mean. And it's a great resource to go back to the RFC and to take a look to see what the values are and why they chose the specific values that they did. And so then here at the end, it sort of wraps things up. One possible use of the route origin community is specified in RFC 4364, which was published in the exact same month, which is all about BGP MPLS IP virtual private networks. Now in here, when I search for site of origin, right, you can see that it's actually called out here as the site of origin. And it just talks about if the site's not a transit VPN site, it may not need to have a unique autonomous system number. Every CE whose site is not in a transit VPN can use the same autonomous system number. This can be chosen from the private ASN space or any of the ASN space, and it will be stripped out by the PE. And this is where that stripped out means that we would be using AS override. And so that's exactly what they're talking about there, is the AS override. And so we've just done the AS override using the neighbor statement. And that's by far the simplest way to do it. There's a couple other ways to do it, and let's walk through some of those right now. So we can go back into the router BGP 67.67, address family IPv4 VRFA, do show run section BGP, and then let's pull that statement out of there. We'll say no, and we'll pull the site of origin out. So now we're removing the loop control that we've put in there. Router BGP 6767 and address family IPv4 VRFA, and do show run section BGP. Whoops. BGP. All right, so we'll drop this out. All right, so the way that we're going to do it now is we're going to use a peer policy template. So, and remember, you can do it with peer groups as well, but you can't do it. It can't be a member of a peer, it can't be using a peer policy template and then try to do a peer group setup with this. It's not going to work. In fact, we'll see the error here in a second. So in order to get the peer policy template set up, we're already in the BGP configuration section. So all we really need to do here is, let me go ahead and exit back out one. And actually, I need to be in that address family IPv4 VRFA. And let's go ahead and say template. Or do I need to be out one? Yeah, template peer policy. Peer policy. And we'll just simply call this site of origin SoO. And I think that is it. So that's it, peer policy template. So we're good there. All right, and then I'm searching here in my memory to remember. So template peer policy, we've got that set. So now we want to set the site of origin. I'm trying to remember here. Don't want to refer to the document. So yeah, so oh, there we go. Okay, yeah, so SoO. So site of origin, and then we would put the value in. So this time let's just use 99:99, just to show that it can be a different value. And then once that's done, I can exit from here, go to the address family IPv4 VRFA, and we add this into, or actually, do we add into the neighbor statement? Or do I? Give me a second here as I'm contemplating. Yeah, we want to do the neighbor. It's, was it inherit? Neighbor 169.254 dot, this is PE7, so 47.4, and I think it's inherit. Yeah, inherit a template. All right, so then we say inherit should be peer policy, and then the template name is SoO. All right, so that should work. So let's go ahead and say do clear VPN v4 unicast star soft. I keep forgetting BGP. All right, so we'll say BGP. So what does our section look like now? So do show run section BGP. So I've basically have the peer policy template set here, right? I have it defined, and then we're inheriting that peer policy. So here's the template peer policy SoO, where we're basically setting that site of origin value to 99:99, and then I, on the neighbor statement, have it set to inherit that peer policy. And let me go ahead and do the same thing over here. So we'll exit up one level, and then we'll say template peer policy and site of origin, and then site of origin is going to be 99:99. So there's our peer policy template. So now we'll go back into the address family IPv4 VRF A, and the neighbor statement 169.254.16.1, and we're going to say, is it template inherit? I can never remember if it's inherit or template. Inherit. All right, inherit, and we're going to inherit the peer policy SoO. And so let's do the same thing here. Do clear BGP VPN v4 unicast star soft. All right, so what we've done is we did the neighbor statement first. Now we're doing it with a peer policy template. But again, the result is going to be the same, where we end up with the extended community site of origin value set for all of the prefixes being learned from each of the respective CE routers. The PE routers are going to go ahead and affix or label the prefixes with the site of origin. And so if those prefixes get exchanged and it sees that site of origin value that matches the incoming from another PE router, it's not going to advertise it back out to that same customer's CE router. And so do show BGP VPN v4 unicast for VRFA, and let's take a look at 1.1.1.1. /32, and we still have the old do show run. Let me make sure section BGP. Oh, you know what it is? Sorry, yeah, I was doing that clear BGP here, but I bet you I've got to. Let's do this. Clear IP BGP star out. So I'm going to refresh my outbound advertisement, which is that 1.1.1.1, and over here, clear IP BGP star out. It's going to be the 4.4.4.4. So now let's come back, rerun that command, and voila. Fantastic. So again, we've got this extended community, site of origin, and the route target, right? So remember, in the Wirehsark packet capture, these were the two extended community values that we saw. And you see the same thing right here. And so again, we're providing loop prevention to make sure that we don't end up with some sort of a routing loop. And so let's go ahead, and the peer group, well, actually, since I said we'll do the peer group, we'll go ahead and do the peer group as well. And you'll actually see that we're going to end up with an error here when we go to do the peer group, because you can't do the peer policy template and the peer group. It's got to be one or the other. It cannot be both. All right, so let's go ahead and jump in here, and I'm on PE1. So let's say, trying to think this through. So do show run section BGP. I want to make sure that we see the error that tells you that you can't do both the peer group statement. In fact, all I need to, you know what? All I need to do is this: 169.254.16.1, and then try to say, I'm pretty sure it's throw the peer group in after this, and that's going to generate, yeah, peer group. So I should be able to say peer group, and then the name of the peer group, just A, whatever. It doesn't matter what the name is. And there you go. So that neighbor inherits a template. It cannot inherit the peer group. And again, it's because the template overrides the peer group if it's set. And that's the message that you're going to end up seeing, basically telling you, hey, this isn't going to work because you've already got a template that is set up. So, all right, so let's do this. So we're going to probably have to pull do show run section BGP. So let's go ahead and pull off. I'm going to say no, neighbor inherit policy, blah, blah, blah. Copy and paste. And then let's go do the same thing here on the other PE router, no. So we're going to get that peer policy template statement out of there. And now we're going to do a peer group. Do show run section BGP. What are we left with? So that's what we've got. So we should be able to say neighbor, and is this the right spot? Neighbor peer. Oh, let's get 116. And actually, no. Hold on. I think I need to be up one. So neighbor. Or was I in the right spot? Hold on a second. Address family IPv4 VRFA. And I should be able to say neighbor, like searching. Is that what I want? Yes. Oh, yeah. Okay, I'm sorry. Yeah, so neighbor SoO peer group, right. So we're going to define the peer group, and then we're going to say, well, no, that doesn't make any sense. I'm actually drawing a blank. Let me take a look here quick. Let me cheat a little bit here. I'm trying to remember too many things. All right, so this actually shows us how to do it. There's a peer policy template, and the neighbor command, and a peer group. Okay, so here we go. BGP, family IPv4 unicast, neighbor peer group name peer group. Ah, so I did have that right. Neighbor peer group name. let's see here. So neighbor peer group name. SoO. Yeah, okay, right. And then I can set the SoO right here, right. So, and then site of origin, and then the value that I want it. So 99:99. All right. I believe we're good to go here. Okay, so we've got that set. We already have the neighbor statement set. So all I should have to do at this point is neighbor 169.254.16. Not 5, actually 47.4, and then say peer group SoO. That should be it. All right, something definitely happened. All right, so let's go ahead and do that over here. We've already removed the neighbor statement. So again, I basically need to say neighbor SoO peer group, and then neighbor SoO, and then what I want to set in that peer group, which is the site of origin value, 99:99, and then the neighbor statement for my 169.254. And over here it is 16.1, and this is going to be peer group SoO. There we go. Okay. Need to slow down in the transition there. All right, so we've got that set. So now let's clear the outbound over here again, and we should be able to do that. Clear IP BGP star out. Router 4, which is going crazy. Clear IP BGP star out. All right, so let's come over here to router 7 and let's check it out. Do show BGP VPN v4 unicast for VRFA, and let's take a look at 1.1.1.1/32, and you can see, and actually I probably should have changed the value, but again, you can clearly see that what we hope to achieve, we actually achieve. So we've got that site of origin value in there at 99:99. And again, the only other way to do it was with the route map, and you can still use the route map to do it, but the neighbor statement is by far the preferred way to deal with things. All right. Well, this has sort of been an epic journey here with BGP site of origin, also known as route origin. Highly recommend taking a look at RFC 4360. It's a great read, a lot of information. So to recap, the BGP site of origin is used in this use case where you meet these 3 criteria. Your site is multi-home to the same service provider, MPLS IPVPN network, and the service provider is using AS override because you're maybe using private AS space or any kind of an AS space number that they don't want to leak out for whatever reason, and they're simply going to override that, and you have an IBGP backdoor peering. And the site of origin is set to prevent loops that can occur, routing loops that can occur if you have these 3 things set up and you don't have site of origin, because the AS override is basically overriding the default BGP loop freedom mechanism, which is the AS path. And that is it. That is really BGP site of origin in a nutshell. All right, well, thank you so much for watching. I hope this has cleared it up. I hope you've got a much better understanding of the site of origin, what it does, when to use it, how to see that it's set up, how to set it up 3 different ways, where to apply it, how to apply it, and what it can do. All right, I really appreciate you watching, and have a great weekend.